Have you ever just looked at the world and thought, man, it's all just one big, unpredictable mess? Well, what if I told you that hidden inside all that messiness, there are these beautiful secret patterns? Today, we are diving deep into chaos theory, and trust me, it's going to change the way you see pretty much everything.
It sounds like something straight out of a movie, doesn't it? A butterfly, a tornado. But this one simple, kind of crazy question gets right to the heart of what we're going to explore today. And it's a question that totally flipped science on its head.
And that's the big secret, you see. Chaos isn't just random noise. It's about these super complex systems that look totally unpredictable, but are actually following a very specific set of rules under the surface. The crazy part is, even if you know the rules, you still can't perfectly predict what's going to happen. The real trick is finding those hidden rules.
So how did we even stumble upon this? Well, our story actually starts with a simple mistake, a tiny little rounding error that accidentally unlocked a whole new way of looking at the universe. It's one of those great stories in science where a huge breakthrough comes from a place you'd least expect.
Okay, so picture this. It's 1961. A meteorologist named Edward Lorenz is using one of those giant room-sized computers to simulate the weather. He wants to check his work, so he decides to run part of the simulation again. But, to save a little time, he just types in a number that's slightly rounded off. He probably thought, it's such a small change, it won't matter. Oh, but it did.
So here's the number Lorenz started with. Just look how precise that is. We're talking 6 decimal places. This one little number was just a single piece of his super complex weather model.
And this is what he typed back in. I mean, the difference is so small you'd think it's totally insignificant. But the result? Whoa. The two weather forecasts, which should have been basically identical, just flew apart, ending up in completely different places. A tiny, tiny change led to a massive, totally unpredictable outcome.
And that shocking result gave us one of the most famous ideas in all of modern science, the butterfly effect.
This is the amazing picture Lorenz painted to explain it. Now, the important thing to get here is that it doesn't mean the butterfly's wings are literally powering the tornado. No way. It just means that one tiny, almost unnoticeable flutter in the air could, over time and distance, be the thing that kicks off a huge, completely different result somewhere else down the line.
The proper sciencey term for this is sensitivity to initial conditions. And this idea is the absolute heart and soul of chaos theory. It basically says that for some systems, like the weather, you can't perfectly predict the future unless you know the starting point with impossible, perfect precision.
But here's where it gets even cooler. So you hear chaos and you think it's just a total mess, right? Well, not exactly. Turns out, when you look really close, a strange and beautiful kind of order starts to show up.
When Lorenz mapped out all the data from his wild simulation, he expected to see a random mess of dots. But what he got was this beautiful, elegant shape. It's called the Lorenz attractor, and it's basically a picture of the hidden order inside the chaos. The system never lands on the exact same spot twice, but it's always pulled back toward this incredible butterfly wing pattern. And this idea of an attractor is huge. It's used to model all sorts of complex stuff, from economics to biology.
You can also see this hidden order all over the place in nature, in things called fractals. Fractals are these amazing patterns that just keep repeating themselves, no matter how far you zoom in. Think about a tree branch. It splits into smaller branches, which split into even smaller ones, all following that same basic shape. Or, hey, next time you're at the grocery store, look at a head of cauliflower. That's chaos in action, and it is everywhere.
Okay, so this is all really interesting theory, right? But what does it actually mean for us? Why does chaos theory even matter in the real world?
Well, it's actually super important in a lot of fields. It's the whole reason weather forecasters can't really tell you for sure if it's going to rain 3 weeks from now. The atmosphere is just too chaotic. It helps scientists understand how animal populations boom and bust. And, maybe most surprising of all, it's absolutely vital to your health.
Get this is so cool. Doctors have figured out that a heartbeat that's perfectly regular, like a metronome, can actually be a sign of a major heart problem. A healthy heart actually has a tiny bit of chaotic change in its rhythm. It helps it adapt to whatever you're doing. So yeah, your body actually needs a little bit of chaos to stay healthy.
Now, because this idea is so powerful, Hollywood loves it. You see the butterfly effect in movies all the time. But here's the thing, they often get the main point completely backward.
So in the movies, it's always, you can go back in time, change one tiny thing, and you get this other totally predictable new future. But the real science of chaos theory tells us something way more interesting.
And it's this. The world is just filled with countless butterflies. Billions of tiny, unpredictable things all bumping into each other at once. The real lesson isn't that you can trace one cause to one effect, it's that the future is and always will be fundamentally unpredictable in the long run.
And that's really the magic of it all, isn't it? Chaos theory reminds us that our world is this beautiful, complicated dance where everything is connected, and even the smallest things we do can have the biggest results. So the next time you feel like your actions are too small to matter, just remember the butterfly. You never know what kind of storm you might be starting.